Oh, right. So math 8, here we go. Week 2, we're gonna do some square roots, cube roots, classifying numbers. So the square root sign is that little check marky sign right here. You see right here. It's called the square, well, square root, right? And so what is the square root? It means what times itself equals 16. Well, we know that 4 times 4 equals 16. So that means the square root of 16 equals 4. Another way to say it is what number squared equals 16? And the answer is 4 squared. And that's why the square root of 16 equals 4. Let's keep going around in a circle. So what are some other square roots? The square root of 36. Well, 6 times 6 is 36, so it's 6. Square root of 25 is 5. Just think of that number that times itself equals whatever is under the check marky sign, aka the square root sign. This is called a cube root. See a little in math, we say cubed for the third power. So this is actually asking you, what number to the third power is 216? You may not know it yet, but I know it's 6. All right, you can check it out. 6 to the third power is 216. So that means the cube root of 216 is 6. Why is this important? Because this is our inverse operation, right? In order to solve for x in this equation, we would cube root both sides. That would cancel out the exponent, and we would get x equals 6. And then later this year, when we do the Pythagorean theorem, we're going to get, a squared equals 121. And I'm going to say, what do you do to both sides? And you need to tell me, well, I know this. I might not know what I do, but I know I do not divide by 2. I'll tell you that much because when would I divide by 2? I would divide by 2 if it was 2a equals 121. Then I would divide by 2 and I would get a equals whatever that is. But this is a squared equals 121. And the inverse operation of the exponent of 2 is a square root. And that's why the square root is important. It undoes the square, okay? And so we would get 11. That's enough about that for now. Talk more in class. So now, solving equations. So I just did that. So we're going to cube root both sides because we see a cube. And what number times itself again is 27? None other than 3. Okay. The second part, so hopefully that'll take a day or less to just think about the same number that multiplies to get whatever we see. But the other part of this week is classifying numbers. So in week 1, we talked about rational numbers. And just as review here, rational is any number that can be expressed as a fraction. Some numbers are fractions, and some numbers, like a whole number 7, can be written as a fraction. Decimals can be written as a fraction. So there's lots of rational numbers, but there are numbers that cannot be written as a fraction. For example, square roots that do not have perfect squares. So what number times itself equals 45? Well, we know that 5 times 9 is 45, right? 5 times 9? 5. Yeah. But the same number twice. No, because 3 times 3, 4 times 4, 6, 5 times. 5 times 5 is 25. 7 times 7 is 49. 6 times 6 is 36. 45 is in between those two numbers. And the decimal is going to go on forever, and it's never going to end. That's called an irrational number. Okay, so sorry, that was a little confusing, but anyway, here's the difference between rational and irrational in terms of characteristics. They both can be written as decimals, but the irrational number never ends and has no pattern. So this, in week 1, we talked about rational numbers that never end. They're repeating decimals, right? But they have a pattern. And an irrational number has no pattern. It's crazy. It goes on forever with no pattern. You know, how could that happen? But there are so many of them. All the square roots that are not perfect squares, and then some special ones I'll show you in just a second. But don't get tricked. 12 divided by 3 is 4. And so not every number is exactly like it seems. Oh, so this is a different assignment called classify numbers. And so simplify if you can. So this is 4. And what is 4? 4 is a whole number. 4 is an integer. 4 is rational because it can be written as a fraction, and it's not irrational. I kind of jumped ahead a little bit there, but let's talk about caveman story here really quick. I told this in class. And so we have these whole numbers, integers, rational, and irrational. So caveman was good with these 3 numbers. He came home to his cave wife and he gave her rabbits for dinner. He hunted the rabbits. And so on day 1, he got 2 rabbits. Then day 2, we got 3 rabbits. So he had to count the rabbits, and that was good. That we needed numbers though to distinguish how many rabbits he had. And then day 3 is bad. He got 0 rabbits. And so all of these numbers are called whole numbers. Whole numbers start at 0 and they go up. No decimals or fractions though. Okay, and so integers, when did that happen? That happened on day 4. He had to borrow a rabbit from caveman Harry over here. Caveman Harry. Got a lot of hair. Okay, can I have a rabbit? All right, so that's -1 rabbit for you, caveman Larry. And so that's integers. Integers go backwards into the negatives and forwards. And then rational numbers are, all fractions. We talked about that. That happened on day 5 when between the 2 cavemen, they only had 1 rabbit, so they had to split it in half. Share the rabbit, share rational numbers. Okay, so all fractions. Half. So that was how it worked. And just another way of looking at it, you got the whole numbers, whole number, and then integers is includes whole numbers, and rational numbers include integers and whole numbers. Okay, so if it's a whole number, it's an integer. It's also rational, right? If it's an integer, it's not a whole number, but it is also rational. It's in both circles. Okay, so a little diagram. Now, irrational, we talked about, is anything that cannot be written as a fraction. But when you're doing this assignment, thinking about it in 8th grade, just look for if it has a pi, or even 8 pi. If the pi symbol is in it, it's irrational. Pi is an example of an irrational number. We know it's 3.14159. Goes on forever, no pattern. and we'll talk more about pi. And also square roots that are not perfect squares, right? So these are examples of irrational numbers. And as you do this assignment, you'll get more examples. Okay, and you'll put all your questions in the organizer. We'll be good to go on Friday, but because we don't have class on Thursday. Bye, guys.